Now, the question I wanted to think about is this: where does the oxygen, the carbon dioxide, come from, even in the first place? So to get us started, we'll go through the first activity. So I want you to pick something around you, just pick up anything around you and then type into the chat the name of what you had around you and what you think is made of. So for instance, I have a pen. So right now I could type into the chat, pen maybe equal to plastic, for instance. I think my pen is made of plastic. So I don't know what you have. So why not do that into the chat? Let's see what people got. Oh, cool. Oh, awesome. Yeah, I'm seeing some interesting stuff. Nice. All right. Awesome. Excellent. So in addition to that, I want you to also type in what you think maybe your bone is made of, or what you think your flesh is made of. Yeah, so you can say, oh, my teeth. You could type in whatever you think. Is your teeth made of metal, or is it made of calcium? Is your bone made of iron or whatever? Let me see what people think. Great, great. Wow, that's exciting. Yeah, so while we are waiting for people to put in stuff into the chat, yeah, so the essence of this activity is just to get us started with thinking like a scientist. So it's very interesting that all of these things you've been putting in here are all great. They are all okay, but as great as they are, they all came from the star. Bomber, right? So the very elements of which we are made of, the very elements from which all of these materials you listed and all of these things around us are made of, all came from stardust. So the news I have for you today is that we all are stardust. Great. So why you are thinking about that, and just to give us a little bit of context, I'm a PhD student. I'm studying massive star evolution using very bright explosions in the universe known as supernova. So today we'll be talking about supernova. So, but before I go into that as well, I'm from the eastern part of Nigeria in Africa, where I had my BSc and my master's in physics at the University of Nigeria in Nsukka. And then I've always wanted to help solve some of the puzzles we have in the universe. One of them is our origin. And so with my research these days, I try to learn about where we come from as humans. And I'm also interested in letting people know about what I finally discovered. So that's why I'm happy with this platform, because I'm telling you right now what I discovered and what other scientists are finding out. So you are in the right place. Let's get started. So I'm going to share my screen and play a video. We'll get started with this video, and I hope it's going to make all of the sense. Okay, so hopefully this goes well. Yeah, so here is an artistic impression of how a very massive star ends its life. So please don't take any of this to be super real, but this is close to real, I would say. So it turns out that a very, very massive star towards the end of their life released a lot of materials that was produced right inside of the star. So imagine how trees in the fall shed their leaves. So this is what's going on. So it releasing a lot of material and they form a circular ring around the star. So you can see the different layers of this material as they are, being released. I'm going to just keep playing. So as it's releasing, it's forming rounds and rounds of this material of the star. And so at a point, it exhausts its energy and then it will explode. Now that explosion is what we call the supernova. Right now is yet to explode. We'll see how it would eventually look when it finally explodes. All right, so it just got exploded. Now you see that all of the material is releasing are also spreading out into space. And then this explosion formed a kind of a shock wave that interacts with this material. So that if you keep going in, you'll see that it will form different colors of light that we cannot see with our naked eye. So the star leaves a remnant, which could be a black hole or a neutron star, while the material that was shedded would continue to spread out into space. Okay, so what is going on here? So usually stars are formed from dust from the Big Bang, and the very prominent dust from the Big Bang is hydrogen and helium. So these two things are the major things that we have for inside of the stars, and so they burn in a certain way to produce oxygen, carbon, nitrogen, and all of the other elements that we know of. Now, towards the end of the life of the star, it will run out of the fuel and share this material and die in form of this explosion. So the star could actually die. Okay, now what we study is the explosion, because sometimes it's difficult to see when it explodes. But after the explosion, we are able to study the material that was ejected as well as the aftermath of the explosion. Using different telescopes, that could of light, we are able to tell different stories about the history of that star that got exploded. Exciting, right? Okay, so I'm going to take a pause here for you to think about these things. I'm going to show us our demo star for the day. So while I stop sharing my screen so that you all could see my star. So this is a cabbage and I hope to eat it afterwards. So imagine this is our star for today. And so just to demonstrate, inside of this star is burning hydrogen. And the hydrogen is forming the helium, forming carbon, forming oxygen at different time scales. So towards the end of the life, imagine that it shares away this material, So, I mean, just imagine that it's shedding away its material just the way, we peel this cabbage right now, and all of these things, are going away. So now, from our understanding of how cabbage grow, we know that the things inside, so the layer inside was, must be very young compared to the ones outside. So it grows from the inside, literally. So when you are looking at this part of the cabbage, the information is going to give you will be different from the information this one that was released earlier would give you. So you get a different pieces of information from this compared to this one. So the star actually releases this material in stages. It doesn't happen this fast like the video was showing, so that we can tell the different life stages of the star just by looking at those materials. because they will form different layers around the star. Let me take some questions from the charts. So the different color lights in the video, do they represent different forms of energy? Absolutely. Absolutely. So the different colors of light were formed at the explosion. And then some of them, you know, the visible light, the X-ray, gamma ray, radio rays, and there are some other ones. If you are not familiar with this, I would just say, think about the colors of light as different wavelengths of light. Yes, so those are different wavelengths, right? So we make use of different telescopes to see these things. So when you're looking at something in the visible, it shows you a different part. It might be showing you what is happening at the interior, where the star was very close to the material. When you're looking in the radio, it will be showing you what is going on in the outermost part, where the materials were thrown out. So this is why it's very good to combine different telescopes to do this study, so you get different insights. Absolutely. So that's how we are able to do this. So for some of the lights, they are able to transmit through our atmosphere and get into the earth, like the radio waves. The radio waves can pass through the atmosphere and get to the earth. So we used ground-based telescopes to see those. We also see optical, even though you can get better optical image when you are outside the atmosphere, like in a space telescope. So some of the telescopes that we use are actually satellites in space. So that things like X-ray that can enter the earth could be caught. Things like gamma radiation that cannot enter the earth, those ones, you know, we make use of the space telescopes to be able to see them. So, but there are a good amount that could enter, like the infrared radiation, the infrared radiation, the radio wave, those ones could enter. So we see them. So the bigger the diameter of your telescope lens, the better resolution image you can get. So if you want to buy a telescope, you want to aim for a much bigger diameter lens. So it's able to, because it has larger area, so it will be able to collect much more light that, you know, that would form the image you want to see. But if it's smaller, it has a small area, so you won't get much. So that's one key thing, I mean, for a personal telescope. Then another thing is to go to maybe a mountain somewhere with height, so that you can avoid some of the contaminations from the cloud. Also, you want to go outside of the city, go to maybe somewhere dark where you won't get contaminations from the city lights as well, to make your observations. So right now we are going to do another exercise. So based on what we have learned, we know the hydrogen born in a certain way to produce all of these other elements. Now, just to note that during the explosion itself, even much heavier elements are produced during that explosion. So what we're going to do now, just to test our understanding. Now, assuming these are different materials from the star, as we all know, they were shaded out. So what do we want to call this material based on what we know that the star probably produced in the inside? So what do we want to call this? Type into the chat if you know what we should call this. Any answer is correct, please. Yeah, let's start with this one. Feel like I should eat it right now. Does anyone know what to do? Okay, yeah, so I'm talking about, can't see it clearly. So this is it. So if this is a part of the material that was shaded, what should we call this? Based on our understanding, this was formed from the inside of the star, and we know what the star is forming. We know it's forming oxygen, it's forming carbon, nitrogen, silicon, nickel, and all sort of elements. So what do we call this? People say they can't see this clearly. So when the star is shedding its material, definitely the mass would reduce, but it is not that significant because the mass of the star could be quite big, and the materials that are being shedded out are, well, in some cases it might be large, but not so significant that the star would probably collapse as a result. So yeah, so I think what I'm getting at with this question is that if the star produce maybe carbon, nitrogen, oxygen, then this could be carbon, for instance, so that when we study these materials, what we will see in the telescope will be that, oh, there are some carbon here, and that's how we know that carbon was formed inside of the star. Now, if I pick up another material using a telescope and then I'm just looking at it, so what is this? What is this? And maybe I see some evidence that this is nickel. And I'm like, oh, this must be from the star as well. So this star actually produced nickel. And that's how we know the star produced nickel. And this is how we do the science. So for every material, you actually get to know what was produced in the star by studying these materials that were released. Okay, so while you are thinking about that, just to help us narrow this down, now these materials that were released, they get into space and form another cloud of mass. So they will continue to spread out until they combine with other materials and they form a very big cloud from which stars will be formed. So the universe actually does this as a recycle, that as it shares this material, those materials are used to form other star systems. Just like our solar system was created from such giant cloud, so it's formed with the planet alongside. That same way, the materials that were released from this explosion would combine together with other materials in space and form a giant cloud. And those clouds will form a star system with their own planets. And so if there happens to be human beings on those planets, they will end up using the materials that are left over from the formation of the system. Just like we are using oxygen right now, we breathe in oxygen, we use carbon dioxide for our plants, we make use of the iron to produce the metals. We make use of the things that Earth provides. And this is what happens. So it's more like a cycle. It just happens that way. And so this is what we learn when we study these explosions. We learn about the materials it's produced. We learn about the life stages at every point in the starlight, what it was doing. We learn about, the remnants at the end of the explosion. What remained? Was it a black hole or a neutron star? We learn about what actually caused the explosion. So these are interesting things because, it not only helps us to understand our origin, it helps us to know where we actually come from. So the takeaway from this is that irrespective of our color, irrespective of religion, irrespective of, wherever you come from, it's important to acknowledge the fact that we all are stardust. We breathe in oxygen from the star, we take out carbon dioxide, and the plants take them. All of these things are from the star. Our flesh is made of carbon, our bones are calcium, and all of these things are stardust. So if we all have that consciousness that we all came from the same origin, probably the world will be a better place. And I mean, just think about that. We all are under the same sky. So no matter the location where you are, we are all under the same sky. So whenever you look up the night sky, what you see is just a dark patch, right? And that's what someone else probably in the north is seeing, and that's what someone in the south is seeing, and that's what everyone on earth is seeing. So I hope this is very helpful for someone as you go out there and try to tell someone that, oh, we are stardust, so we are the same. So at this point, I would like you to go through the resources that I've sent earlier on. Maybe you propose that again. Feel free to use them, learn more about some of these exciting things. And I'm happy to continue this discussion over maybe Twitter or wherever. I'm sure my Twitter handle should be up. Yeah, great. Adaeze Ibik. So feel free to ask me any question, and I'm happy to answer them. Thank you. So, so we all know that gravity rules the world, right? So anything that has mass definitely would experience gravitational force. So these materials, as they are thrown out and they spread out into space and come in contact with some other huge materials. So gravity pulls them together, literally. And they are pulled together, they begin to, become compact, they begin to form spherical balls and fragment into smaller balls. And this, causes the heating of the balls. And that's how this continues until it's hot enough to ignite the burning of the hydrogen. And that's how a star is birth. This is how you give birth to a star. So, and this happens simultaneously with the formation of the planets. If that cloud will be able to form planets. So all of this happens simultaneously. For me, when I study these amazing things, it kind of blows my mind. Like, it makes me realize how small, how small we are on Earth, and even in the so-called solar system. Because my study has made me realize that the universe is huge. It's really huge. So it just gives me a perspective of where we are. We are just like a tiny pale blue dot. I'm sure you must have seen the pale blue dot that a satellite took on its way out, So it gives me that perspective overall. I don't know if that's what this question is about. Or something like, if you think about the origin of life and how we all are made of the same material. Like I said, so we are formed by the materials of the planets we live in. Just like we are on Earth, we are formed by the materials of Earth. Some other people in other planets will be formed by the materials of where they are, and also in other kind of systems, other star systems that are not within our solar system.